Let's write the Lewis structure for sulfur dioxide. So sulfur dioxide, generally we try to make these things symmetrical, so we're going to put the sulfur in the middle and an oxygen on each side. And then how many valence electrons should we have? Oxygen has 6 and sulfur has 6. So we have 3 atoms that each have 6. Means we have 18 electrons to mess around with. So we'll start out with a bond here and a bond there, 2, 4, 6, 8, 10, 12, 14, 16, 18. We're short a pair of electrons. We need to make a multiple bond. So I'm going to take a pair of electrons from the sulfur and share with this oxygen that is not having an octet right now. This sulfur and this oxygen both have octets, but this guy doesn't. And we're doing ones that obey the octet rule, so everybody has to get their octet. I'm going to take those guys off and make a double bond. What if we started out and went a little differently? Again, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now it's sulfur that's not having the octet. What if we take a pair of electrons from this oxygen and make it into that double bond that we need? Now, are these Lewis structures the same? Not quite, right? They both involve a double bond between sulfur and an oxygen, but if we identify the oxygens, let's make this guy a little different color. This is a pink oxygen on the left. And we can identify these in actual compounds. Here the double bond is with the white oxygen, and here the double bond is with the pink oxygen. Those are not exactly the same, but they both follow the instructions that we've learned for drawing Lewis structure. The actual molecule is between these and is neither of them. So either of those structures we drew predicts that SO2 has one double bond and one single bond. But we know from experiment that both of the bonds are the same. They have the same length and the same strength. And so it's intermediate between a single and a double bond, kind of like a 1.5 bond. You're like, well, how is that possible? Well, it's kind of complicated. But what we do is we say, well, Lewis structure is not going to allow us to draw a 1.5 bond. We can't draw a structure that shows that both of these bonds are equivalent. And so what we do is we draw a structure with the double bond in one position and in the other position, and then we put a double-headed arrow in between. And this indicates resonance. So one way to think about it is that the molecule is flip-flopping back and forth between these two structures, going back and forth. It actually isn't. It is in the middle. It's between these two. But resonating, you think about bouncing back and forth. It's between these. And this is just the best way we can draw that using Lewis theory. So let's draw a Lewis structure for nitrite ion and include resonance structures. Nitrite, NO2, so we'll want to put the nitrogen in the middle and an oxygen on each side. We have to count up electrons. Nitrogen has how many valence electrons? 5. And we have 2 oxygens, and they each have 6. And the charge is -1, so we add an electron. So we've got 18. So we'll put a single bond here and a single bond there. That's 2, 4, 6, 8, 10, 12, 14, 16, 18. We don't have enough electrons for an octet on everybody. The nitrogen's short. So just like with the SO2, we have to make a double bond. We have to choose between these two, though, because these two atoms are both oxygen. And how do we choose between them? Well, this is a situation where there's a resonance structure. So the way we do it is we choose to put the double bond in one of the positions, and then we write the structure again with the double bond in another position. Some compounds can have 2 or 3 or 4 resonance structures. And it's when you've got to choose between two atoms of the same element to put that double bond in. So I'm going to choose to put it on the left one this time. And then this is an ion, so I need to put brackets and a charge on it. There's the charge. And then over here, I'm going to draw the same structure, but I'm going to put the double bond on the other side of the nitrogen. And then between them, I'm going to make a double-headed arrow, and that indicates that these are resonance structures. The true structure is between them. Any questions?